The letters and the post office question we've solved using the fundamental principle of counting. I can give a small formula if I want to. The formula is nothing but n raised to the power of r. N raised to the power of r. How do we convert this as formula? The number of permutations of n different things taken r at a time, where each thing can be repeated r times, is equal to n raised to the power of r. The number of permutations of n different things taken r at a time, where each thing can be repeated r times, is equal to n raised to the power of r. Now, in this particular formula, if I am using n raised to the power of r, I must be clear as what should be taken as n and what should be taken as r. So, in our question, your n is equal to 5 and r is equal to 4, and therefore, it is equal to 5 raised to the power of 4. That is the question for the letters and the post office problem. If someone is not clear or not sure about what should be taken as n and what should be taken as r, he may take n is equal to 4 and r is equal to 5, and he will write the answer 4 raised to the power of 5. So this answer will be right and this will be wrong. That means what? The person who is taking up the formula n raised to the power of r is not sure as what should be taken as n and what should be taken as r. Now, we understand first that, and then we apply the formula n raised to the power of r. It can be applied to situations like this, and there are many situations which we come across where n raised to the power of r formula can be used. Now, if I am typically taking the letters in the post office question, I am picking up the letters and dropping them into the post office. That means what? There is one particular thing which is receiving the other, or the one which is accepting the other. The one which accepts the other is n, the one which gets accepted or is received by the other is r. That means in the case of letters in post office, the post office are picking up the letters or receiving the letters, that is taken as n, and the letters are getting accepted or moving into the post office, they are taken as r. Now suppose I take 5 fingers and 4 rings. There is no restriction. On one ring or on one finger I can put all the 4 rings. That means I am taking up the ring and putting it to the finger. That means there are 5 fingers and 4 rings. That means what? In that case, n is equal to 5 and r is equal to 4. Therefore, 5 raised to the power of 4 is the answer. Now, similarly, I can talk of a student and a bench. Now, there are 5 benches and 4 students, where we assume that on one bench, all the 4 students can be accommodated. In that case, what happens? All the 4 students can occupy the bench. The first student can go and occupy any of the bench. Second one can go and occupy any of the bench. Third one can go and occupy any of the bench, and similarly the fourth one. That means here, the benches are the ones which are stationary. That means what? The students go and occupy the benches. That means the benches receive the students in one way. Therefore, benches is equal to n and students are is equal to r. Therefore, again, it will be equal to n raised to the power of r formula, which can be applied. Now, suppose I am talking of a buttonhole and a button. If I am talking of a buttonhole and a button, now buttonhole is what and button is what? We understand. Here, suppose if I am taking the buttonholes, I am just taking out the button and putting it here. One thing we have to understand is here, I cannot put all the buttons in one hole. That is a problem. Second thing is, in one button, a buttonhole, all the buttons cannot be put. That's one thing. Second thing is what? The order cannot be changed. Therefore, typically in the case of a buttonhole and a button problem, the formula of n raised to the power of r cannot be applied. Therefore, we don't apply in every situation where that particular situation, the one which is receiving the other should be in a position to accept all. Only in that case, we apply n raised to the power of r formula. We take up more questions on this particular idea of n raised to the power of r.